we're going to start the last of the big three topics in calculus. Did limits, did derivatives, now we start talking about integrals. Or, the process by which you find an integral is called integration, just like when you find a derivative, that's called differentiation. So finding an integral is using integration. I got some more working room up here. I like this a lot. Okay, antiderivatives and indefinite integrals. So what do you figure an antiderivative does? The opposite of a derivative, correct. How about an indefinite integration?
Goes on forever.
We'll get there. Not quite. Yeah, we'll do some differential equations. That sounds scary. And then we got some indefinite integrals and some notation. We got a new symbol today.
Ooh.
Oh, he did show up. Wait, no,
They pulled us aside to the side room when we weren't changed. Then the locker room was locked.
Excuses.
And we went 5 minutes to arrive.
Wait, hold on. Hold on.
Yeah, get the tissues, please.
All right, go ahead.
That's all I had to say.
That's all you got?
I think you're late for this class a lot.
You will tell me the basic rule for taking an integral, and then we'll talk about this. Not today, though. This comes later. Antiderivative. Undoes a derivative. So, for instance, if we start with this little function, 3x squared, what function, when you take the derivative of it, gives you 3x squared? Nope. X to the third.
Plus something. Maybe.
Plus something?
We don't know.
What do you want a plus?
Plus or minus C.
Why?
That could be in there, we don't know because it's just the derivative.
Huh?
Like,
It
either
could be
x,
any number.
x cubed plus 6, the derivative would only be 3x squared because the plus 6 would be 0.
So there's not one answer?
No.
That could make grading rather difficult for me.
You chose this profession.
I did. So capital F now comes into play. So up until this point we have 3. F of x, f prime of x, f double prime of x. Now we're going to go backwards and look at capital F of x. So that's the antiderivative of f. It's going backwards. Lad, lose the iPad. Every day. Stop it. So if I start with a function x cubed, I take the derivative of x cubed, I get 3x squared. Now we're going to go backwards and eventually get to what Will was talking about. Oh, by the way, it's called antiderivative. We knew that. Okay. So, astute observation, my young friend. If I take the derivative of x cubed plus 7, I get 3x squared. If I take the derivative of x cubed minus 12, I get 3x squared. How many different possibilities are there? There are an infinite number of answers. There is one catch, however. What is it that we add or subtract onto the function? What must be true about them? Also known as? A constant, right. It's got to be a constant. This is called a family of derivatives. So how does it change? It's the exact same graph. It's the exact same function. It's just been slid up and down. So x cubed plus 3, or sorry, x cubed plus 7 is the x cubed graph that's been slid up 7 units. The x cubed minus 12 graph is the x cubed graph that's slid down 12. So you just got a bunch of functions just stacked up on top of each other. And that's what makes this what's called an indefinite integral. We're not getting one answer, we're getting an infinite number of answers. And all of them are correct. So how do we represent that? Does that mean that every time I grade a problem, I have to look at your constant and make sure it's a constant? So that one person might have x cubed plus 7, the other one might have x cubed minus 12, the other one might have x cubed plus pi, someone else might have x cubed minus e. That would be a pain in my butt. So therefore we're going to use this, which is called the constant of integration, capital C. That represents all the possible constants that you could stick on the back end of that. So for instance, this will come up later, but I'll ask now, What's C plus C? Nope. C. Why is it just C?
Because it doesn't matter.
I don't know what C is. You take a constant, you add another constant to it, you're going to get another constant. What's C squared? C. Square root of C? C. Is there anything I can do to C to not get C? What's C minus C? It's C, not 0. Yeah. How are we doing so far?
That is not you.
And that plus C is going to cause you a lot of grief because you're going to forget about it. And so when you take the antiderivative of x squared, when you take the antiderivative of 2x and you get x squared without the plus C, it creates a whole nother world of hurt that we want to try to avoid. Okay, so here's my function. Now I gave this in a different form. I started with y prime. Let's suppose I started with y quadruple prime. What's the antiderivative of y quadruple prime?
Capital Y,
Nope.
Y to the third prime.
Yes. Y triple prime. Okay, so you're always going back one. If I take the antiderivative of y double prime, I get y prime. The antiderivative of y prime would be y. And it just keeps going backwards. It's a little hard to introduce the capital letter here, but that comes up later. Okay, so then that plus C shows up again. Not rocket science, it's pretty straightforward there. The nice thing about it is you can check it. By now you should be masters of derivatives. So you take the antiderivative, you're not sure if the answer is correct, just take the derivative of it. If you end up back where you started, you did it correctly. If you're not sure that the square root of 64 is 8, how can you check? Take 8 and square it. You get 64, then you're good to go. By now you should know, by the way, that the square root of 64 is 8. Okay, so new notation. New symbol. That little squiggly guy. You can draw that a bunch of different ways. This is where you get a little bit of creativity. It just has to be legible. So some people will try to just do that little S-looking thing. Some people will go the big solid dot and then try to put the big solid dot over there. Some people go like crazy new techno on me or something. Other people will get all fancy. Probably don't want to do that. You just need a symbol that represents the integral. That's not so good, that's not so good. This is okay. This is preferred. Go ahead, try one.
Mine's on.
And then look at your neighbor and see how he or she did. If they did not do a good job, then feel free to ridicule them. Not bad. Not bad. What do you got, Jack? It's all right. It's beautiful. It's great. Okay, so that thing that you're taking the integral of, or the antiderivative of, is called the integrand. Just like when you take the square root of something, the thing underneath the radical symbol is the radicand. This dx is very important. It's called the variable of integration. The reason it's so important is because it tells you which variable we're talking about. Now this is kind of obvious. We've got x's everywhere, so we're working with x. But strange things happen. Suppose, for instance, I had the following. What's the antiderivative of y squared dx? What's my variable? It's not y. X is my variable. That's what this does for me. It tells me what my variable is. My variable is x. So if my variable is x, what can you tell me about y squared? What do you consider it? Just becomes a constant. Like pi, like e. Is that what you said? Say it loud, say it proud. You didn't, so you lied to me. You did or didn't say it? Huh? What? When? When? Huh? Huh? Who? Why? When? Who? Did you say help me? You just answered the question. What is this? Okay, let's do this. What function when you take the what function when you take the derivative of it gives you 2? 2x. Yeah, good, plus c, nice. What function when you take the derivative of it with respect to x gives you y squared? Plus c. Okay. That's why this is so important. It tells you what the variable is. And you'll forget about it, and then you'll lose some points, and then you'll learn to include it eventually. But it might take a couple bouts of trial and error. That's the antiderivative. We knew that already, and c is the constant of integration. So those are all the parts that make up that equation. That's already what I explained about the dx, so we're good to go. And these are indefinite integrals because we don't get one specific answer, we get a whole bunch of a family of answers, if you will. Okay, so let's take a look at this guy first. 2 special cases. These aren't normal integration cases, they're special cases because notice what I'm taking the antiderivative of. And by the way, I use those 2 terms interchangeably, integral and antiderivative. This is different than what we looked at already because here I'm taking the antiderivative of a derivative. So what do you figure the antiderivative and the derivative would do to each other? Cancels out, and we get back to the original function, plus c. We're good with that idea, yes? Just like taking the square root of a number and squaring it, you get back to what you originally started with. Same thing as adding 2 and subtracting 2, cancels each other out. Any problems there? What did I do first, the derivative or the integral? Derivative, inside out. Okay. Okay, what about that? Now I'm taking the derivative of an integral. So the big question is, where's the plus c for the second one? Why?
Because if you take the derivative of c, then it would just be gone. It's not anymore.
Because the derivative of a constant is
0.
good. Okay, subtle point, but fairly important. What did I do second? Well, in this case, what I did second was the antiderivative, which gives me a plus c. In this case, what I did second was take the derivative. And as Stephen said, when you take the derivative of a constant, it goes away to 0. So this was capital F of x, and then when you take the the derivative of capital F of x, you get to f of x. No c. Okay, small subtle point doesn't pop up very often. It will become more relevant later on, but for now, just an interesting thing that you may want to, or that you should know. Okay, now we got to figure out a rule here. How am I going to take the antiderivative of x cubed? Or more importantly, what is the antiderivative of x cubed? Oh, it's not stupid. It's okay. No, we still know. And that's not incredibly wrong, by the way. No. What function, when I take the derivative of it, will give me x cubed? Say again?
X cubed y.
Nope, we don't want to throw another variable in there. That'll cause somebody to cry. Me in particular.
1/4 x to the 4th.
1/4 x to the 4th.
Yeah.
Oh, Tim just gave you an oh yeah.
Ooh, oh, spicy.
So that's got to. Somebody just say spicy?
That was no.
Okay. 1/4 x to the 4th. Is he right? No. You forgot something. Plus c. Now is he right? Is the antiderivative of x cubed with respect to x equal to that? Well, how do we check? What's the derivative of 1/4 x to the 4th?
X to the cube.
X to the cubed, right? And what happens to the c?
0.
Goes away. Beautiful. All right, you ready? Stephen? Let's see if you have this under control. What's that?
1/7. No wait, it's 1/8 x plus c.
Wait. What's that?
Isn't it 1/8 x?
1/8 x to the
8th power
8th
plus c.
plus c. Yes or no?
Yes.
Yeah, because bring the 8 down, that cancels, reduce it by 1. C goes away. Okay, you ready? Here's the last one for you, Steve. What about x to the nth? Now let's generalize, because if we can come up with a general rule, then we'll be golden, because that will work for any polynomial function.
1 over n
1 over n,
x
x,
n plus 1, right? Yeah.
x raised
X raised to the n plus 1.
n plus
plus
1
c.
plus c. How do you do?
Almost.
Almost correct, Les?
Yeah,
Do tell.
yeah, in the denominator of the fraction, it should be n plus 1, because it has to cancel out.
You agree?
Yeah.
So this,
Yeah,
are you sure?
I'm sure.
What happens when you take the derivative of that?
It becomes, actually, yeah,
Bring the exponent down. I get n plus 1 over n plus 1. Reduce the exponent by 1. You get x to the n. Good. Nicely done. What if there's a constant out in front of it? Let's suppose I come back over here and put a 2 here. What's that going to do to my answer? One over 4. Yeah, because it just puts a 2 out front. It doesn't matter. Okay. This is the same thing as 2 times the integral of x to the 7th dx. Just like when we were doing derivatives. If you're taking the derivative of 6x to the 3rd, you just put the 6 out in front, leave it there. It's not going to bother anybody. Take the derivative of x to the 3rd, and then multiply your answer by 2. Good. Now we got a rule. So we can apply that rule all the time. There it is.
awesome.
Which is exactly what we had. Well done.
You did it, guys.
Don't forget that plus c. That'll get us going for basic polynomial functions. That'll get us pretty far, actually. And then we'll run into some stumbling blocks. What stumbling blocks could we encounter?
Quotient rule.
Quotient rule.
Chain
rule. Product rule. All 3, some major stumbling blocks. Anything else? Praying?
Crying.
Crying is a stumbling block.
Yes.
Sometimes it's cathartic.
And you get a headache, which is like.
Not always. I don't get a headache when I cry. You get a headache every time you cry?
I'm dehydrated already.
Which is like, you like crying is supposed to like.
Do you just cry dust?
Eventually it stops. Cold air.
Air comes out of your eyes. That's great. Hey, how about the T word? Trigonometry?
Oh.
Oh yeah, oh yeah, we'll get there. By the way, here it is in English. I like this statement reciprocal better than the 1 over n plus 1 because if, for instance, it's easier to illustrate if I show you an example. What's the integral of x to the 2 thirds? X to the 5 thirds. What's out in front? 1 over 5 thirds, which is easier to just use the reciprocal, like I said down here. Okay. Raise the power by 1, multiply by the reciprocal. Oh, plus c.
Do you have to include that every time?
Yes, sir. Not every time. Later on, we'll take antiderivatives where there is no plus c. Those are called definite integrals, but you're not ready for that yet.
Yes.
What's that?
We're ready.
No, you're not. Your head would explode.
Yeah, is the Christmas approach work for that?
Well, it won't hurt. That's for sure. This is really important because it's in a flashing starburst. Okay. Write what down? The formula, or this is really important?
You didn't write the formula.
Okay, ready for some good news? There is no product rule, chain rule, and quotient rule. You know how important this is? It's gonna flash. Yes. Don't stare at it too long, you'll have a seizure. Even though I showed you something in a flashing red starburst, you know what many of you are gonna do? Product rule, quotient rule, chain rule on integrals. You're still gonna insist on trying it. I don't know why, but maybe you run out of ideas, backed up against the wall, you got nothing else to do. You should cry before you do this, yeah, because they're not the same. Well, there is a bad side to this, in that we have to figure out ways to take antiderivatives instead of using the quotient rule. We got to come up with other ways to do it. Those necessarily aren't that fun, but more manageable than the product rule, quotient rule, and chain rule. Okay. But those are in the future, not today. Today we just care about the T word, trig. Hey, yeah. Hey, look at these. That's kind of weird, isn't it? Why isn't it just sine, cosine, tangent, cotangent, secant, cosecant? Why do I got to fire off these bizarre things? Why would I do this? Well, look at the right side. Look what's on the right. Oh, what's the derivative of tangent? Secant squared. What's the antiderivative of secant squared?
Wow.
Yeah. Slicker than whale dung in an ice floe.
Excuse me?
Yeah, you right.
Some confusion comes about in that when we've taken the derivative of sine and cosine, one of them has a minus sign and one of them doesn't. You probably have that filed away in your brain now. But now when you start looking at the antiderivatives, it gets confusing. I'm not particularly proud of this, but the following, I should say. But I do have a method to remember which one has the minus sign. Okay? It's called the stupid golf thing. And it goes something like this. Let's suppose I want to take the antiderivative of the sine function. There's a reason why I put a big dot on the end. The dot on the sine becomes a golf ball, and the integral symbol becomes the club. And when you hit that golf ball, it travels so fast you don't even see it. It just becomes a blur.
Oh. That's insane. That's supposed to be easy.
Again, if it doesn't work for you, then don't use it. If one of you gets that right because of the stupid golf thing, I've done my job. If it confuses 29 of you, I have not done my job. What's the matter? You are such a baby.
Wait, but what about for like the cotangent, like,
I don't have a cool golf thing for the, or stupid golf thing for the cotangent.
or for the cosecant?
Nope. So you might be saying to yourself, well, wait a second. Can't the O in the cosine become the golf ball?
Oh,
No, you couldn't hit a golf ball from between a C and an S. They're in the way. This is clear. You can hit that. This you can't hit. That's not a golf ball. That's an O. Quit being stupid. No golf thing. Golf thing over here. No golf thing over here. No minus sign. No golf thing.
You hit it slow, so you don't see that blur, because it's between the C and the S. So you don't see the blur.
Well, it wouldn't go anywhere. It'd just bounce back and forth.
So you just have a sign positive.
Sure. All right, take the antiderivative of that bad boy.
I think you're supposed to.
Where'd you have to hide? In the studio? Yeah. Did you play with cameras and stuff? Oh, we're danger, ah! So, did whatever they're locked down in the locker room?
No, there's no in there.
I would think
They close the locker. That did sound
Oh, yeah, yeah, yeah. No,
This, the journal is
yes, it is.
actually there.
talk about that. So we're all on the same page. How many C's do you have? Rach, how many C's do you have? One? Well, technically you have two, because there's a C in cosine, but that's just me being an idiot. Aussie, what did you get for the antiderivative of this first?
2x to the 4th
How'd she do?
Yeah.
Good, keep going.
minus 7 cosine x
Nice.
plus,
Did you use the golf thing?
yeah,
She did, but she's just
plus,
Danny,
wait, with the 7th
Silencio. Go.
Plus,
1 C. How many people had 1 C?
Yeah.
Why not 2 C's? I did 2 antiderivatives.
we don't know what to see.
What's C plus C?
C.
C, you only need 1 C.
You see?
I do, right there.
Yeah, nice.
Any problems?
Hey, if you take the root
Easy
of
peasy?
negative cosine
Awesome.
x,
Oh, I see what you meant. I see.
Good job, Rachel. When we were doing derivatives, whether you realize it or not, we followed a similar procedure. Take your original derivative, rewrite it into a form that works for you, take the derivative, clean it up. Same thing happens for integrals. Take the original integral, rewrite it. There's some of them that you might want to rewrite into a more workable form. Then take the integral, then clean it up if you need to. So for instance, find the antiderivative of that. You're not going to rewrite 12x to the 4th, but how are you going to rewrite the cubic root of x times 5?
15 x to the 1/3.
15? We're not taking an integral yet, we're just rewriting it.
Oh, no, then just
5x to the 1/3, and how would you rewrite 1 over x to the 5th?
X to the negative.
X to the negative 5th. Good. Antiderivative of 12x to the 4th minus 5x to the 1/3 plus x to the negative 5th dx. Beautiful. Tim, you got the first one. What's the antiderivative of 12x to the 4th?
Let me think about this one. 12 to the 4th would be. It doesn't work like this, Mr.
Doesn't work like what?
Backwards.
Oh, I'm sorry. Should we just throw it all out? Hope they don't show up on the AP test?
Hopefully.
Okay.
I'm sure.
Some of these are gonna be like,
Is it 12 over 5x to the 5th?
Is it 12 over 5x to the 5th?
Sounds good.
Solid. Raise the power by 1, multiply by the reciprocal. Well done. Connor, you got the second term. What's the antiderivative of negative 5x to the 1/3?
3 over 5. Oh wait, hold on. Is it 4 over 5x to the 4/3?
I'll give you the x to the 4/3. But you got your constant wrong. First of all, it'll be minus, right? Okay, what goes out in front?
5 over 4/3.
Oh, I see what you're saying. I'm sorry. You're right, 5 over 4/3, which is? Dividing by a fraction, same thing as multiplying by the reciprocal.
15/4.
15/4.
Wow.
Maddie, you got the last one.
Minus 1 over
Minus 1 over 6
6x
x to the 5th?
x under the denominator.
No. Oh, I see, you want it, you're skipping a step. Leave it as a negative exponent.
X to the negative.
Because -5 plus 1 is -4, which you caught on the second part, but not in the first part. That's wrong. Plus c. Now, Scott don't care about simplifying, we don't like that.
I feel like
I'm more concerned that you can take an antiderivative, then
I'm gonna get my.
you can put that back in the denominator and do all that other gunky stuff.
He's gonna cry.
Okay. Any problems? We'll stop there for today.
3.14.
Eventually, what's going to happen is we're going to come back to derivatives, back to integrals, and start looking for definite integrals, which would be an integral where you get one and only one answer instead of the whole family of answers. But that doesn't come for a while. We got to do a whole bunch of work ahead of time before we can get to that point. Okay, so first it becomes practice of the problem.